Hello and welcome to lesson 3 of week 8. In this lesson, we are going to look at hash sets and how we can implement it in Python. My name is Mildred. A hash set is an unordered collection of unique elements, and it uses hashing to store and retrieve items efficiently and typically in big O of 1 average time for insertion, deletion and lookup. So we want to have a custom hash set, and we'll use the open addressing linear probing methods to implement this. And in the last lesson, we already looked at the different variants of all of these Python. We'll create a custom hash set, and we'll see that we can just use a normal set in Python to do a hash, just the way we create a set with unique values. The way we use the inbuilt set method is just the same, but let's implement it so we can get a proper understanding of hash sets. So let's create a class called hash set. Now, the init method, we want to get the size. Let's just call this, let's give it a different name in this example and call it capacity. Let's say init self capacity. Now we will define them, because now we're collecting only the capacity when the object is created, but we want to have a size or initial size of 0, and we want to have the capacity of the table to be the number of buckets, or we want to have the number of buckets of the table to be equal to the number of capacity, the capacity that is specified, right? So let's say self.capacity. Now I'll say self.size. We will say the size will be equal to 0, and then we'll say self.table will now be the none. So the capacity here doesn't mean the size, but it's actually going to function as the size like we saw in the last lesson. I will explain it as we go along, so just hold on. So let's create the hash function like we did previously, and we'll say the hash function and self key. We want the hash to just be, we'll hash the key using the inbuilt Python function hash modulo the capacity, so we have all of the indexes within the size of the table. So we'll return the hash of the key modulo the capacity. Right now we want to have the add function. Let's call this function add, and we'll say self and the key we are going to add, and then we'll say this is going to add an element to this set. We'll say if self.contain, if it contains the key we want to return, so we want to prevent duplicates. This is what we are trying to do, just like prevent duplicates. But if it doesn't, it ignores this, and we'll get the index will be equal to self. So you can actually use knowledge from the last lesson. It's just similar, everything we're doing is similar. So we'll do self. We hash the key, and then the start index will be, our start index is going to be the index, this index was created. Now we want to loop through the table, and so we want to say while there are items in the table, we want to set the index. So the start index will be the index, and while there are items in the table, when we loop through, anywhere it gets to is going to be the new index. So let's do it like this: while self.table index. So while the index is not none, while there are items, we want to say the index now will be equal to the start index we have plus 1. So we're moving to the next index. So the start index plus 1 modulo the capacity. So this capacity in this case is just like the size in the last lesson that we used, but we have a size parameter here that we're going to use. We're going to increment this size as we go along, and you're going to see what this size means. So I can change it to say this is size and this is capacity, so as not to confuse you. But when you see capacity here, it's just exactly what we meant when we say size in the last lesson. But in this, it doesn't mean the size, because we have something else called size that we're going to see. So we'll say if the index is the start index, we want to raise an exception that the hash set is full, right? So we can't insert in it. Raise exception and say hash set is full, something like that. And then now we can now say the index of that table will be equal to the key, and we'll say the size is equal to 1, so there's 1 item. So now bringing us back to the size of the table. The size here we mean is how many items are in the table. So we have the capacity of the table to be, let's say we supply capacity to be 10, and we mean capacity here to be the number of buckets that we have, and we mean size here to be the number of elements that we have in the entire table. So how many buckets are filled up. So when we put this here now and we loop through to insert, and we go through and we don't have anything to insert, and if the index of what we want to insert already exists, we want to not insert it there. And now after the whole looping, we want want to date the table index to be the key. So self.table index is the key that we're adding, and then we want to update the size of the table now to be one item has been inserted, right? So self.size plus 4. So now we have one item in the table. So you always get the size of the table. Okay, so we start with a table that has 10 empty buckets, and now we have one bucket is filled. So only one item is in the table. So the size means the number of items. We are going to go through this code again when I just finish writing it now. So now let's create one that we use to check if it contains something. So let's say def contains, and we want to search a key. So this contains is just going to be boolean that will say yes, it contains this, or if an element exists in the set, yes. If it doesn't exist in the set, you will return false, right? So we want to check this. We always start with the index, will be self.hash the key. So we use the hash function. Now the start index will be equal to this index. So say start index. Now you know that sets in Python, normally things are not ordered, they are unordered, and it's the same thing with this, is unordered. So you always have to set the start index, and then we want to now loop through like we did when we were adding. Say while self.table. So while self.table index is not none. So while self.table index is not none, we want to say if the index is equal to the key. So if table index is equal to key, we want to return true, so it contains the item. And if not, we'll say index will be equal to index plus 1 modulo self.opacity, and we'll say index is equal to the start index. We want to, let's break here, and then to return true, break, return false. Alright, so now we just want to check this if it contains, and if it doesn't contain, we will return false. So let's do one that we can use to delete, or let's say remove an item. Let's just create this function. You can create as many methods as you want that will handle your functionality. Let's say the remove self key, and for this remove method, we want to say, let's get the index first. The index is always self.hash key, so hash function key, and the start index will be equal to the index. Then now we want to loop through, and then we'll set it to none when we find that key. So we'll say while self.the index of the table, so while self.table index, okay, is not none, we want to say self.table index is equal to the key. We want to, let's say print removing, so removing, let's do it like the last time, removing key, the removing key at index position index, then let's set it to none. Let's say self.table index equal to none, and then we'll set the size -1. So we'll say self.size minus equal 1, and we return, we'll return here, and then here we want to say the index. So if this is not the case, so this is going to be checked. If this is not the case, it will continue to set the index will be equal to index plus 1, let's say modulo self.opacity, and then we'll set the, let's check that if the index is equal to the start index will just break. So say if index is equal to that index, break, right? And then here we can now raise an exception to say that the key is not found. So we'll say raise key error, and we're going to raise this custom error, the key that the user supplied not found. You can have any kind of custom error that you want. So we're going to be raising the key error. Let's see that when we want to get the length of it, we'll just return the size to see the amount, the number of items in it. So we can say def, let's use this len magic method self, and this will just return self.size. So we know that the size is the length. And let's do a display function now for we test. Let's say display, and we want to display everything in the table. We'll say, let's do it like a table like the last time. We'll print, and I'll print a new line always, and then I'll say index. So this is the heading and value, something like this, and then I'll print a line beneath. So print a line. And now I want to now get the key value pair. So I'll say for I, let's say for the index value in enumerate self.table, we want to print, we'll do it in tabular form. Let me format the row, maybe center it. So I'll still use I and the caret 5. This is just to format how the items in the cell is centered, and I'll use the 5, and I want the value. So the value is val that I used here, val. Now let's try to use this. So let's say if name is equal to main, we'll say let's create something, my set is equal to hash set. So we have a hash set, and let's say we'll supply the capacity to be 7, and then let's say my set dot add, we'll add apple apple, let's add apple, banana, grape, and another apple. Let's add duplicate. So we'll say apple, banana, grape, and apple again. So we want to say this duplicate, and we'll see how it's ignored, because we know that set is unique. So duplicate ignored like this. And let's use the display to display the table. My set dot display, and let's print something out here. Let's check if it contains something. So we'll say contains, let's say want to check if it contains banana like this. So we'll say contains banana like this. Let's ask a question, and then here let me put an arrow. I just want to print out something well formatted. So I want to say, does it contain banana? We'll use the my set dot, we created a method called contains here. So we'll say my set dot contains, and then we'll pass in the banana. All right, so we're just printing this to see. And let's remove banana now, and let's see and print after. Let's say my set dot created the remove method, and we want to remove banana, and then we want to print after removal. Let's say a removal, and then we'll just display my set dot display. All right, so now let's run this, and we can see that it's working. For the first time, we have no error on it. So we have the hash set that we implemented. This is just like how the set in Python, the inbuilt set data structure in Python functions. But we implemented this, and we can see that here it gives us the items that we have, and when there is no item, it puts none when we loop through to display. And that's what we created here in the display method. Here we said if we insert or add an item there, we insert. If it's not none, we loop through to get it. And so because we created a bucket filled with none, the capacity is filled with none, so we get none for the empty ones. And so here we can see that 0, index position 0 is none, 2, 3, and 6 is none, and we have something inserted there. Contains banana, it gives us true because we use the contains method. So we'll say removing key at index position index. So here I want to remove the key, so I think I didn't format it properly. So we want to say removing, I'll put the key in curly brace like this because I'm using the format. Let's use the format string here. So removing key at this index. And so when let me clear and run again, so we'll have it well formatted. So we have, okay, removing banana at index position 0 because banana is at index position 0 in this run. And so now contains banana, we remove banana at index position 0. After removal, we'll print, and banana is no longer there, it's set to none. So all of our methods work. So you can create more methods. Like in Python sets, there are methods that you might not have inbuilt. You want to create your own hash set like this, and do all the methods that you want to use to implement a set in Python. Okay, so the inbuilt set type is a hash set implementation and uses the hash table internally. So when you use those sets in Python, sometimes it's good to use the inbuilt ones. It makes it faster since it's already inbuilt in the program. So under the hood, when we have a Python set, it computes a hash value for each element using the inbuilt hash function. It stores that element in a hash table slot. So the array index is derived from the hash. It handles collision and open addressing, like the methods that we covered earlier, and it maintains uniqueness by checking for existing elements with the same hash. As we see, we try to insert apple twice here. It just ignores it and does not insert a second apple. And we'll see on our table, we only have apple inserted once. So we can use the normal set in Python. You can refer to past Python lessons to look at how the set sequence type was used and all of the methods we have access to. The real world cases for hash set is when you want to remove duplicates from a list, when you want to check if maybe like a user ID, you want to implement unique user IDs or unique emails, you want to detect maybe circles in a graph, or you want fast membership testing, things like that. So that is an example. So there are different operations you can do with the sets. You can use the inbuilt set data type. In the next lesson, we are going to look at hash maps in Python. Thank you, and see you in the next lesson.